Hi, welcome to our first lesson in Algebra 1 this year. We're going to begin with Unit 1, which is expressions, equations, and functions. We're going to start off by learning how to evaluate expressions and follow the order of operations. So by the end of this lesson, you should know exactly what to do with all that. These are the standards that we'll be addressing throughout our lesson today, and then Calvin and Hobbes for your viewing enjoyment. What a great way to start off. As we're going through this lesson, a few things that you should keep in mind are that you will have notes that you should be taking as you go through the key points of the lesson and examples to look back on. Feel free to pause and rewind at any time if you missed anything or want to copy something down. So let's get going. Expressions. An expression is something that we do in math that we can write out. It can involve addition, multiplication, subtraction, division, powers, square roots, any kind of operation that we want to do. And we're just going to begin by talking about how to evaluate. Let's take this expression here, 7 plus 8. If you saw that, you would say, oh, that's 15. Okay, that is what is known as evaluating. I'm taking that expression and I'm simplifying it down as much as I can. Let's take another expression. Now we're going to throw some letters in there. It's algebra now. We're done with all those numbers. We're going to put variables in. A variable means we're taking a letter, A, and it's representing a number. So in this case, A is 7 and X is 8. So if I evaluate that expression, if A is 7 and X is 8, this expression you would say is 15 also. Okay? We just threw a different variable in there to throw you off a little bit. We have the same expression, A plus X, except this time A is 12 and X is 10. 12 plus 10 is 22. So same expression. Oops, what did I do there? Same expression. The only difference is we get a different value because we have different values for our variables. Let's take a look at another expression. This one seems kind of odd looking. We've got a bunch of different words in there that stand for different things. You guess what this is used for? This would be a fantasy basketball scoring expression. So we take the player's points, rebounds, steals, add those up, take half a point for an assist and half a point for a block, and subtract a point for every field goal that they attempt, for every turnover they make, subtract half a point for every free throw they attempt, and half a point for every foul. And so this would evaluate how good the player is. A better player would score more points based off the statistics they get during the game. So that's how expressions are used. Now, if you're following along in your note sheet, you'll see that you can copy this in. If you don't have a note sheet, you can start just writing down some of the key words that we'll be using in this lesson. So the first one we have is a variable. A variable, as I mentioned before, is a letter that's used to represent one or more numbers. An algebraic expression is a collection of numbers, variables, and operations. Operations we mentioned were like adding, subtracting, multiplying, dividing. Okay, we're combining numbers with variables now that we're in algebra. When I evaluate an expression, all that means is I'm substituting the number in for the variable and performing the necessary operations, simplifying it down like we did with those previous examples. Feel free to pause the video and copy down those definitions. All right, let's now get into how to evaluate some expressions. So let's say, for instance, we've got these expressions. 7t. Well, what does that mean? Well, it means I'm multiplying 7 times t in math. When you see the variable right next to the number, that means we're multiplying. X over 20. It's another way to write down that we're dividing x by 20. That's division. Y minus 8. You've probably seen that before. It's subtraction. 12 plus a. And that would be an addition. Okay, so let's take a look at some of these algebraic expressions down here. We're going to evaluate these expressions when n is 4. Okay, so we're going to take the variable n and put 4 in its place. So 4 times n, or 4 times 4, would be 16. In this case, 8 divided by n. So if n is 4, 8 divided by 4 is 2. And over here by my face, we've got 15 plus n. So 15 plus 4. Simplify that expression down as far as we can, we get 19. Okay, so that's the basic algebraic expressions that we'll be evaluating. Next, we'll get into powers. That's another operations that we can get to. There's some vocabulary in there that you'll want to copy down. But a power is an expression that represents repeated multiplication. So it's a way to save time. Mathematicians want to simplify as much as they can. So a power is just multiplication many times. We have the base number. The base number is the number that's used in the repeated multiplication. So in this case, we have 3 to the 4th power. Okay, 3 will be that base number. So we're using that number, repeating that number and multiplying it multiple times. How many times? Well, the exponent tells us that. The exponent tells us how many times we're multiplying that base, how many times we're using that factor. So the exponent will be written above the base. So here, this little 4 means that we're taking 3 and multiplying it 4 times. So 3 to the 4th power. Simpler way to write 3 times 3 times 3 times 3. And if we wanted to simplify that down, 3 times 3 is 9, times another 3 is 27, times another 3 would be 81. Okay, so let's take a look at some of those examples down below. Feel free to copy some of those down. So this first one, 12 to the 1st power. Okay, the way we would write that, well, 12 is the base. We're multiplying it 1 time. 2 with a 3. So 2 to the 3rd power. Another way we can write that is 2 cubed. Cube has 3 dimensions. So that's another way to say that. So the product is 2 times 2 times 2, 3 times. The mistake many people say is, oh, repeated multiplication, so it would say 2 times 3. But remember, exponents mean we take that base number 2 3 times. We can use fractions as well, 1/4 to the 2nd power, or we can say 1/4 squared. Square has 2 dimensions, so we can use squared. So I mean we're multiplying 1/4 2 times. That could be simplified if we wanted to 1/16. And we can use variables as well, a to the 4th power, which means we're taking a 4 times. So a times a times a times a. Okay. All right, moving along. That guy's confused a little bit. So we need to evaluate this expression. The expression says 4 plus 6 divided by 2. I think he's a little confused because he doesn't know which operation to do. Before we were just using one operation. It's pretty straightforward. Now we've got 2. So if we take 4 plus 6, that gives us 10. And then we take 10 divided by 2, that gives us 5. Okay. Another way to do this will be to take this expression and we take, well, let's do the division first. 6 divided by 2 is 3, so I've got 4 plus 3, and 4 plus 3 is 7. Notice the final simplified products are not the same. So that's the question, what do we do? So luckily, in math, we have a way to fix that, and that's called using the order of operations. The order of operations is a way that we in math make sure that when we write something, it follows the same pattern so that when someone else solves the problem, they'll get the same solution. so we're not confused. A way that we use to remember that is a fancy mnemonic device called "Please excuse my dear Aunt Sally." And the way that helps us remember the order of operations is please, notice it starts with P, that stands for parentheses. Excuse starts with E, that stands for exponents that we just talked about. My dear, M and D stand for multiply or divide. And the AS for Aunt Sally stand for add or subtract. So we've really got 4 levels that we work through when we're simplifying an expression in order to know which operation to do first. So as we see there, we evaluate inside the parentheses. Oops, I lost my writing there. I'll get it. Where did I go? Parentheses. Next, we evaluate exponents. Then we multiply and divide from left to right. So that's a key thing there. It's not multiply before divide always. We just take step 3. It's either multiply or divide, whichever one comes first, left to right. Then once we're all done multiplying and dividing, then we do whatever's left with adding and subtracting. Same thing from left to right, whichever one comes first. See if I can write that in. Okay, feel free to copy that down so that you have that and can refer to it later. So let's take this expression on the bottom, 6 plus 12 divided by 3 times 4 squared. So according to our order of operations, we need to look for parentheses first. There are none. So next we go down to step 2, which is evaluate exponents. I see some exponents there. 4 squared. Lost my cursor. So 4 squared, there we go. 4 squared is 16, so I'm just going to rewrite the whole expression down so that I don't get confused. And then I can evaluate from there. Next, after exponents, I have no more left. I evaluate by multiplying and dividing from left to right. Addition, division, multiplication. So I'm at the multiply divide level, so I do the first one that shows up left to right. So 12 divided by 3 is 4. Rewrite 6 plus 4 times 16. I still have multiplying and dividing left, so I finish that up. 4 times 16 is 64. And then I go to the add subtract level. There's only one left. So 6 plus 64, that gives me 70 when I finally simplify it all down. Okay, let's do some more work with that. Notice this first one here. We've got some grouping symbols. Okay, when there's multiple grouping symbols, we evaluate inside out. So we've got this set here. This one's further inside, so we do that one first. 2 plus 6 is 8. So I've got 3 times 32 divided by 8. Parentheses can take the form of brackets as well. Still inside parentheses, so 32 divided by 8 is 4. 3 times 4 is 12. Okay. Next one is kind of tricky. We would think 8 plus 4 divided by 5 minus 2. Typically we would divide first, but when it's written in this form, we've got a numerator and a denominator. There are imaginary parentheses there, so we need to simplify the parentheses first. So we've got 8 plus 4, and then we've got 5 minus 2. Simplify that down, 12 divided by 3 is 4. Okay, try the next example. All right, you can try this next one. Pause the video, see what you get. Okay, so let's check it out. So here's the work that we get for it. We put the 3 in for B, 3 to the third minus 21 over 5 times 3 plus 9. We evaluate the numerator and denominator first. So within the numerator, we get 3 to the third, which is 27, minus 21. On the bottom, we evaluate by multiplying first, so 5 times 3 is 15, plus 9. Simplify the numerator to get 6. Simplify the denominator to get 24. We can simplify 6 over 24 to get 1/4, or 0.25, depends how you wish to write it out. So that's it. That's all there is for this lesson. You should know how to evaluate mathematical expressions now and follow those order of operations so that you get the correct solution every single time. So do those practice problems. Bring any questions you have to class. You can check over the solutions online, and then you can apply your knowledge with the application problems. We'll see you later. Bye.